Welcome, everyone. This is Professor Dan. I'm a professor at the instructor at the University of Colorado, and I'm putting together some things on TinkerCAD and Onshape just to help students learn how to use these tools for when I'm not around. So what we had and what we left with is the way to turn on a light using just some batteries. So without using Arduino, we could turn a light on. That's enough of that. So what we learned, the limitation of this is that, yeah, we got to sit there and hold the light on. That's pretty boring, pretty lame. So if we use an Arduino, we can actually use a button as a sensor, and we can sense the state of the button. But there's some weird little nuances. So let's get this going together and see how far we can get. So I'm going to get rid of our batteries here. And we learned that the power of buttons, or the power of Arduino, is we can isolate our circuits and combine with code. So in this video, we're just going to learn some nuances about how to make a button a sensor, and then how to read that sensor with Arduino. So I've got our Arduino, I'm hitting the R to rotate. And the first things first, we want to get our Arduino connected to our button. So a lot of times people say, all right, we have a sensor, we need to power it up with 5 volts. There we go, 5 volts, make that red. There we go. And then we need grounds. There we go. And so people want to start a button with that. That way when I hit the button, something happens with my Arduino. What it does, though, is it connects 5 volts directly to ground, which is also known as a short circuit. Now, my guess is Arduino has stuff in it to protect it, fuses and whatnot, but if I start the simulation and hit that button, nothing happens because we're not taking a reading. We're not using this button as a sensor. So let's stop that. And let's use pin 8 as a reading. So pin 8, all of these pins from 0 to 13 are digital pins, which means they're able to, actually they're digital I/O pins, input-output pins, which means they can either turn on all the way or turn off all the way or take a reading that is 5 volts or 0 volts. All right, so if we use pin 8 to take our reading, and I'm going to choose my yellow wire, don't know why, just like yellow. And then in my code, it's going to give me blocks. And you know, they didn't ask me, but I do not like blocks. And they always give you blank code. I don't want a blank. I want to read from my sensor. And then my sensor in this case is a button. So how do we program this up? What does it look like? So we want to have pin 8. So we tell Arduino we want to use pin. That's our pinMode command. We tell it what pin 8. And remember, this is going to be a sensor. So output from sensor, input to the Arduino. So we'll call that an input. And in our previous videos, we've learned that it's always good to take our readings and assign them to a variable. So I'll call that integer B state, button state. I don't call it butt state because, I don't know, it's kind of funny. Creepy laugh, sorry. And what do we want to do? Well, we know the reading is going to be high or low. So it's not analog, but it's digital. And we want to take a reading, digital read. And what pin? 8. Then from our previous videos, we want to print that on the screen, and we learned that the command to do that is serial.print, and we learned a little trick to put an ln so that all of our readings aren't printed out in unreadable line. We have it's actually a carriage return and a new line command. Serial print line B state, there we go. And in our B state, sorry, I did that really quickly. Our B state is just what variable B state represents. So if it's high, it's going to be either 5 volts, but I think it'll be a 1. And if it's low, it'll be a 0. And remember, we have to do Serial.begin in order to use this thing down here, our serial monitor. And we want to do Serial.begin 9600. There we go. So let's try it out and see what it tells us. And it says that no matter when I hit my button, it's always 1. So I hit the S command, stop the simulation. If I bring it down to the other, maybe I hooked it up to the wrong terminal. I hit S. And now it's always 0. And that's because this is reading the voltage. When the voltage is connected to ground, it's always 0. When the voltage is connected to power, it's always 1. So what we have to do is we have to use a little bit of circuits knowledge. And so we have to use this thing called a resistor. And we'll actually go through this circuit a little bit later on in this video. And in our circuit, in our SIK kit, we learn that it's a 10K. And we can also see that we can hook up the 10K to power. We get a voltage drop across the resistor that protects our Arduino, so that's a good thing because we have a voltage drop, but we also have a current limiting resistor. And then we take our reading on the leg that's attached to, this is terminal 1A. Cool. And then the other terminal is attached to ground. So let's switch back to our code, start our simulation. Ooh, it's always 1. How many of you expected that? When I hit the button, it switches to 0. So when the button's not pressed, it's a 1, and when the button's pressed, it's a 0. It's probably a little counterintuitive. I think it makes sense for us to switch, go through a little circuits 101. All right, so here we go. What does our circuit actually look like? Well, that's our symbol for ground. That's GND. Oops. That's ground. We go up. Our ground was connected to our switch. That's a symbol for switch. This was pin 8. Pin 8. Oct if you're German. That's our 10 kilo ohm. Then we had 5 volts. And so in the Arduino world, pin 8 is taking a reading. It's taking a reading whenever we do that digital read command. When we connect pin 8 to ground, and that reading is actually a voltage reading. So it's saying, do I have 5 volts or do I have nothing? When I connect pin 8 to ground, I'm doing that physically by pushing on the button. I push on that button, I connect this pin to ground through that black wire. I push the button, push, and I connect pin 8 to ground. Ground equals 0 volts. Cool. So when I push the button, I get 0 volts. But the question is, why do I get a 1 volt when I'm not pushing the button? Well, the answer is because, well, it's actually a little counterintuitive. Because a lot of people say V equals IR. That's Ohm's law. Thanks. Ohm's law. And so don't I get a voltage drop across this resistor? Why don't I? And that's because delta V is IR. And when we have an open circuit, when our button's not pressed, that's an open circuit. Think of it like a switch that's off. There's no current going through there, which means delta V is equal to 0. And delta V is the V here, V1, V2. V1 or V2 minus V1 is equal to, it's picking up my hand, equal to 0. So V2 is equal to V1. And so we know V2, V1, V2 is equal to 5 volts, which is 1 in Arduino digital read. Cool. So that's how that works. But let's say we want something a little more intuitive. A lot of people like having, and this is known as a pull-up resistor. Is there a way to do a circuit that will give us a low reading when the button's not pressed and a high reading when it is? Sure. Our circuit simply looks like this. We have our ground. We got our 10 kilo ohms. We have pin 8, octave for German, 5 volts. So now, when I connect it, connected, pin 8 is reading 5 volts, which is 1 Arduino digital read. And if it's not connected, I simply, am reading 0 volts because we don't have any power connected to this. So let's switch back. All right, so now how do I test that out? Well, let's see. Here we go. So we have our button, we have our resistor, and now we simply need to move our locations. So let's move that up. Let's move our button to there. We still want to have our resistor connected to our button. So we have 5 volts coming in. We have our button. We are now reading from terminal 2 instead of terminal 1, and then we're connecting a resistor to ground. And then we're taking that reading on pin 8. Code stays the same. Let's see how it goes. All right, so there we go. Starts with a 0, hit the button, goes to 1. Hit the button, goes to 1. All right, so now how do we get this LED lit? It's Friday, got to get things lit. All right, so what does that look like? Well, we isolate our circuits combined with our code. So what does that look like? So let's use pin 13. Let's bring it on over. And we come to ground. And then we got plenty of black wires on TinkerCAD. So now we're using pin 13. We got to tell Arduino we want to use pin 13. How do we want to use it? Well, the power's coming out, so it's an output. And now we have to do our if statements. So if B state is high, that means the button's pressed, we want to do something. And that is digitalWrite 13, high. Else B state equals up. Well, if it's not high, it's going to be low. So I can do else digitalWrite 13, low. And be careful, there's an error here. All right, what's the error? The error is when we're doing logical tests, you need to do a double equals. Look, when we have a single equal sign, that is assigning the value of digital read to the variable B state. If we want to test what the variable B state is, we have to use a double equal. It's really something you're going to forget, and you're going to be looking at your code and trying to figure out why your stuff's not working. But there you go. All right, so double equal sign to test. So if it's 1, we turn the light on. If it's not, we turn the light off. Here we go. We hit the button, it's 1, turns the light on. Hit the button, it's 1, turns the light on. There we go. All right, so now what we did though is just go over exactly what we went over in our last video, except we ended up spending about $25 on a new Arduino for doing this for real. So we turned a light on and off with an Arduino. And then we added another resistor, and we added a whole lot of complexity. We could have turned the light on and off with the last video. So now we have to think about the power of Arduino, what it's giving us, so that we can actually make this button a toggle. And we're going to save that for the next video. All right, so I hope you enjoyed this one. I'll see you in the next one when we do toggle switches with Arduino. All right, we'll see you. Have a great day.